acknowledgement to country. So I'd like to begin today by acknowledging the traditional custodians of the land on which we meet today and pay my respects to the elders past and present. I extend that respect to any Aboriginal and Torres Strait Islander people who join us here today. Thanks to David for coming along. We tipped us off this a few weeks ago, and it looks like it's a pretty good bit of software you got here. That'd be good to learn about it. Prith, you want to give a bit of a background to everyone here?
Yeah, sure. Hey everyone, name's Prith. So I think I'll just get right into it. We're here to hear a bit from David. So we're probably just a very brief background. We're all in different phases on our asset management journey. Some of, we've got a heavy focus on condition assessments. Some are focusing on maintenance optimization. And while others are doing, full-fledged reliability-centered maintenance processes, and some are doing all of the above. So I think we're all in different areas, different phases of asset life. So today's focus is really just to share what some of us are doing with a company like Arms Reliability or Baker Hughes, as now it's called, and how David has been involved in some of those initiatives. We just have an opportunity to learn from that, and if there's any other questions, we can ask at the end. But yeah, just want to hear from David on how he's been involved in upskilling and delivering some of those programs that help in the whole asset management reliability space. He'll provide a brief introduction, some of the projects and the training courses that they provide, and also it's got a software as well and demo if time persists. But I'm really looking forward to the Q&A session. I think, is it fair to say we can put questions in the chat, Lisa and Callum, while David is presenting, and then we can attend to them later?
You read my mind, Prith. I was just putting it into the chat.
Okay, perfect. So feel free to flood the chat with questions. David will be more than happy to answer them. So yeah, we'll get to it at the end. So I'll hand it over to you, David.
Thanks, Prith. Thanks for the intro. Thanks, everybody. Okay, so I do have a few slides to share. So what I'll do is I'll just fire that up and I'll share my screen, and then hopefully we can talk through them. Let me just do that. Right, can you see my screen okay? I've just lost you, so let me push you over there. There we go.
Yep, all good.
Excellent. All right, so right, so my name David Turner. I've been with Arms Reliability now for 13 years now, and prior to that I was working for Honda UK Manufacturing and Quality as an engineer, as quality engineer, I guess, ultimately, and moved through Honda up through management, and then finally decided to move to Australia and joined Arms as a consultancy engineer. And as that, working as an engineer, got to see many different industries around Australia, did lots of traveling, saw lots of different companies, and really trying to help them with their reliability issues, and trying to help them put in ultimately some packages of work to try to improve that reliability. So working from Arms Reliability as a company, I guess, I'm not sure if you've ever heard of us, but as a company, we are a reliability engineering based consultancy company, and really we cover a few key areas, I guess. The main one really that we cover really is reliability engineering services. So we'll perform reliability engineering based projects, and those projects really are tailored towards helping our clients trying to improve their reliability. And we may do that with some software, and we may not. We tend to be focused more around maintenance and maintenance task optimization, but that can vary into looking at assessments of assets and general improvements towards risk mitigation and so forth. And we can provide mentoring support. So as a company, you know, we've been in business since 1995. We've got about 100 engineers now globally working on reliability-based projects. So as a company, I guess our whole workforce is now probably around about 150, I suppose, but of those 100 plus, I think we're up to 107 as of yesterday, I think, globally are working on those engineering-based projects as a majority. So that's the main sort of focus of what we're working on. But in addition to that, we have some software, which we started to develop relatively recently. And I guess that software, again, you may or may not have heard of it. It's called 1PM, and it's a reliability focused software. And I'll talk through that a little bit in a few slides. But that is slowly becoming one of our, certainly our larger portion of our work. We have a team of technical development team who are fully focused on purely developing that software. And then the final piece, I guess, of our revenue stream coming into ARMS would be training, and that's where I come in, because my job role is global training manager. So I look after all the training that we deliver externally to all our clients, and that training may take the form of reliability or RCA. We also do some training that focuses around the sort of solutions that we offer with 1PM, and that's really focused on asset strategy management. And then we also do some additional training that is purely focused on using software, and that software might be 1PM itself, or we might have some other companies which we buy software or use their software, such as Isograph. And those courses, we can deliver them as public courses. So we have a series of public courses that we have on our website that people can book onto, and we can also provide private courses which are specifically tailored towards what the client requires. So that's our kind of our three main streams going into ARMS. And then really, you know, the main sort of work that we're doing then is we're either working on, I guess the majority of our engineers on a day-to-day basis are working on maintenance strategy builds for some form of capital project or brownfield site of some kind, and that's mainly what they're doing. And then with that, they're looking at the asset strategy management side of how companies are managing their assets, what maintenance are they doing to support those assets, how they're trying to mitigate the risk around those assets, and then building the relevant strategies and then pushing those strategies into their CMMS, into their SAPs or their Maximos or their Ellipses or Oracles or whatever management system they have for managing their maintenance. And then I guess this third bubble that you can see over the top here is this sustain piece. So as ARMS, I guess over the years we've very much got into clients and helped them initially with some small project. And help them produce maybe a maintenance strategy for an asset or a series of assets or an entire plant. And we would go in and perform that work, and then we'd probably pull back once that project is completed. But more recently, certainly with development of 1PM, we're now more interested, or we certainly have a high interest in trying to sustain and support those clients with their maintenance strategy on an ongoing basis. So it's not just a single project that we get involved in and then pull it back. We continue to support and ensure that those maintenance strategies are evolving as there's always changes going on with design or process or demands on the particular plant or system. So that's kind of our main sort of avenues that companies would turn to when they talk about ARMS. In addition to that, we also do some availability modeling. So we'd be looking at, say, a plant and trying to validate what the availability of that plant might be based on loss of reliability. We can also look at the capacity. So when I say capacity here, I'm talking about the throughput of that plant. We can model that and look at how that might be impacted by the reliability and maintainability of the equipment. And we can do that again on an existing plant, or we might want to do it from a design validation viewpoint. And then similarly, when When a project is completed its initial stages and it's getting ready for operational readiness, then again, we may support those teams with ensuring that they are ready for operations. Have they truly validated the availability of their systems and their processes? Are they ready in terms of maintenance and so forth? And we can support that. And likewise, a large part of that operational readiness may be master data development. So they may want to ensure that their SAPs or their Maximos are fully populated with the relevant data, and that master data often can be triggered from maintenance-related information. We also offer root cause analysis and defect elimination support in terms of training, but we can also, if someone has a problem that they want to bring maybe a third party in to do that root cause analysis facilitation, then we can support that work. And then sometimes we also get involved with vulnerability or risk assessment style support. And historically, we've also been involved with asset investment planning as well. Not so much these days, but historically we used to. So that's kind of a bit of a snapshot of the sort of stuff we do. And, you know, some of the clients that we've dealt with, there's some logos you can see there on the screen. You know, this is just a snapshot from whenever, but it's constantly changing, and we bring in new clients, and some of the clients move away once their projects are complete, and it's a continuous cycle of change, I guess. So really, I guess what I want to focus on more is on the water industry and some of the projects that we've worked on that are water industry related, and certainly we've done quite a bit of work with South East Water, which obviously is why I turned to Prith to try to see how I could get involved with this particular network. So I'll talk about the South East Water in a bit more detail for some of the work we've done on that. And similarly, we've done quite a bit of work with Icon Water over in Canberra. And again, I'll talk about that because this is a good example of where we brought 1PM in as a software tool to support Icon Water. We've done a lot of work with Water Corp over in Perth. A lot of work around developing an asset library of strategies that we were able to validate following a reliability-centered maintenance or a failure mode and effect criticality analysis style approach to ensure that their maintenance strategies that they have in place are justified. And those are really for all their main key assets and facilities. And once we've developed those maintenance strategies with Water Corp, we wanted to ensure that they actually got implemented. And to do that, we developed with them effectively a load sheet to ensure that those maintenance strategies could then be pushed into their Maximo instance. And as part of that project, we also did some work with taking some data that they had in another piece of software called RCM Turbo. They wanted to try and pull that data out and put it into either a different piece of software or onto a different format. So we were able to configure a little tool that was able to help them convert that existing data. With SA Water over in Adelaide, again, we've done a lot of work with them around RCM-based maintenance strategy development, a lot of work around availability modeling on some of their wastewater treatment plants. Me personally, I've been over to Adelaide numerous times, working on the availability studies on some of those wastewater treatment plants and water pumping stations. And we also did a little bit of work on some of their co-generation powerhouse facilities that they had there in place, looking at the maintenance strategies around those facilities in particular. We've done work with urban utilities up in Queensland. Again, we build a lot of maintenance strategies across a lot of industries, and as a result of that, we build up quite an extensive library of equipment and maintenance strategies that would support that equipment. So that means that companies can turn to us, and we can help them with providing perhaps a baseline maintenance strategy for a particular piece of equipment that they've got, and we can then use and leverage that library of strategy work that we might have to try and speed up the work of developing a maintenance strategy approach for maybe a whole new site. So that was some of the work we did with urban utilities. We did a lot of work with Sydney Water going back, where we actually had a long-term engagement with an embedded engineer who was supporting development of, again, more around reliability improvement, covering maintenance strategies, covering availability modelling, and just generally trying to level up the internal staff there at Sydney Water with a reliability-based program. With Water Care and over in New Zealand, again, RCM, availability modelling, again, looking at our water treatment and sewage networks. With Goulburn Murray Water, we did a little bit of work with Goulburn Murray Water to try and improve some of their problem remedy codes that they had on their irrigation regulators. So a little bit of work with those people. And then just down the bottom there, I just looked through some of the other projects that we've done that perhaps haven't been quite as large necessarily, but certainly we've done work with Metro Water over in California, Tidewater, Barwon Water. We did a little bit of work with those people, and then some of the other logos on here, such as BHP and MMG. Well, those are obviously enormous mining companies, but they have their own requirement for water treatment, whether it's water going into the actual sites and process or water that's going into support some of the mine camps that they have. And they have their own sort of smaller scale water treatment plants. So again, we'd be supporting those guys with maintenance strategy work for those particular processes. So let's just touch on South East Water and what we've done with South East Water over the years. So one of the main things that we've tended to focus on with the asset management team really at South East Water was developing reliability block diagram models and looking at their main water recycling plants to try to ascertain what the availability of those plants would be, taking into account the reliability and the maintainability of the assets that are involved in those plants. So essentially what we're trying to get out of these projects is really trying to put some quantification around the system availability, reliability, and really the overall performance of those sites, taking into account the reliability of those assets and really looking at what the risks may be to certain consequences that may occur if assets or systems or plants within those water recycling plants fail due to a reliability or maintainability viewpoint. So we're trying to look at that. We're also trying to capture some other criticality assessment viewpoints, look at which of our assets then are giving us the highest impact to loss of availability or loss of capacity, and then trying to put some metrics around that to give us a bit of a Pareto or a list of those assets that we should be focusing on. We're also including with that what improvements we can make from a maintenance viewpoint, obviously which assets from a reliability viewpoint do we want to focus on so that we can look at renewals of those assets or general overhauls, or what should be the viewpoint from a shutdown approach. And really then, once we've built our model, which is capturing the availability of those plants, that gives us kind of a baseline starting point for the current situation, but we can then use that then to support future changes to that plant, maybe some design changes or process flow increases going into that plant, and just see what impact that availability is gonna have as a result of those changes. So that can be used, I guess, to support again future investment in certain areas of the plant, maybe defer investment or accelerate investment as a result of risks that perhaps have been highlighted by those availability studies. And I guess as almost an additional item that comes out of those assessments is we do include, as part of the maintenance work that we're capturing is the spare parts. So what spares are required to do the certain tasks that are needed to either renew the life of an asset or from an inspection or a planned maintenance viewpoint. So those spare parts are captured, and then we can use the software that we have to try to look at, well, how many spare parts should we actually hold on site or off site, and how many should we not hold? So we can do some form of spares optimization for that work. And I guess finally, as a result of doing this kind of work, we do get some benefits as a result of reviewing the actual assets themselves and the hierarchy, And just by going through that review to perform this availability study, it helps us make some recommendations towards improvement of the asset management. SE Water did, or probably still do, I believe, use their own watershed tool for capturing their assets and maintaining those assets. So again, we can offer some guidance as a result of doing these projects to look at improvements within that. And again, improvements to pin IDs, process flow diagrams, spares holding, and so forth. And we've done these projects with South East Water now at a variety of sites: Mount Martha, Summers, Bonio, Pakenham, Blind Blight, and Lang most recently last year. So you know, it's an ongoing series of projects that we've been doing with South East Water. So when we talk about doing the reliability block diagram modeling, essentially what we're doing is we're taking process flow diagrams, piping instrumentation diagram data, and we're converting that into a series of RBD blocks to try to represent the logic of how those assets interrelate with each other. You can see here what a typical layout may look like for a very simple kind of system where we've got wastewater coming through into a plant, going through inlet works, through the primary sedimentation, and out through various other systems within that plant. So we're trying to capture that logic as simply and logically as we can. And then we'll need to add on to those blocks any failure and repair data that effectively is our reliability and maintainability data. And then we can also add in an understanding of what the consequences would be for loss of availability, either from an entire plant viewpoint or a series of subsystems within that plant. They may have their own consequences of loss of availability. And then we maybe want to add complexity to the modeling to try to represent reality. So there may be buffers or phases that we might want to add into the modeling to make it more representative of reality. Certainly the Mount Martha site for South East Water has got a couple of very large emergency storage lagoons that offer some protection to the entire site, and we can model that as a form of buffer. And likewise, phases come into play. We may have different failure data that is applicable for, say, summertime versus wintertime, and those changes in failure modes and failure frequencies can be applied into the model to make the necessary adjustments to availability. We can also model capacity and capacity loss as a result of reliability, and we can also finally look at spares and so forth. Once we've got that base modeling, that's when we can then start to look at the scenario modeling. So there's kind of the what if scenario. So what if our process flow increases by 50% over the next 5 years? What impact is that going to have from an availability viewpoint, given the assets that we have currently modeled and the throughputs and the reliability and maintainability that we currently have on those assets? One of the other kind of indirect benefits of doing all this work really is that it actually brings together the SMEs, the subject matter experts on these assets, and those can be brought in from operations, from the M&E areas for maintenance or asset management, and often it's a good kind of situation where we're bringing all these teams together just to focus on the reliability of these assets. And often it's not often that all these guys would necessarily get together in the same room just to talk about reliability improvement. So the project in itself indirectly can be quite beneficial just from that viewpoint. And ultimately we'll get out some results. We'll get some sort of Pareto style results to an availability, and we'll try to kind of group those together in certain patterns of where we think focus areas should be performed. We can look at our output from a risk viewpoint in terms of a particular consequence. How many of those particular occurrences may be occurring on each year? So, and therefore, what is the risk, and is that acceptable or unacceptable? What measures can we take to try to minimise that risk? And then finally, I guess we will ultimately come up with those alternate scenarios where we might want to model different situations and see how the model then performs with the data that we're putting in. So in terms of Southeast Water, that's the kind of the reliability, availability kind of studies that we'll do. In addition to that, with Southeast Water, we've also done some work on modelling maintenance strategy activities. In particular, we've looked at the sewage and water pump stations, and over the years, these have been done repeatedly, and we tend to break those models down into different categories of the pumps or the pump stations that are being modelled. And we use a piece of software to do this called Isograph Availability Workbench, which kind of looks like this. And you can see here what we're doing is we're breaking those pump stations down into their core elements, and then breaking them down further into the maintainable items, such as the pumps and so forth. And on those particular pump areas, we'd then be following an RCM, a reliability centered maintenance approach to analysing those particular assets. And we break those down then into understanding what the core functions and functional failures, and ultimately the failure modes would be on those particular pumps. Because once we understand what the failure modes are, we can then ascertain what maintenance we should be doing to try to mitigate those failure modes. So we use that piece of software to do that work, and we've done that numerous times with Southeast Water, and often we'll produce some graphical formats and so forth to help them from a cost profile viewpoint, which they can use then to some of their own reports around understanding what labour, equipment, spares costs might be over a forecast period. So that's Southeast Water. We've also done a lot of work with Icon Water. And the difference really, I guess, with Icon Water is we're trying to model or capture all their assets. And they've got a lot of assets. They've got over 700,000 assets. So when we're trying to put that amount of assets into a piece of software, I mentioned before about Isograph's Availability Workbench, which is really a desktop package application. Really, when we start talking about that quantity of assets, it becomes too much for a single piece of software like that. And that's where we then bring in more of an enterprise style solution, which is where 1PM comes into play. And so for Icon Water, we're using 1PM to do a similar kind of activity work of maintenance strategy capture, but on a much bigger scale with many more assets. So the general flow that we use when we're using 1PM and we're doing this asset strategy management style approach is we're very much trying to focus on trying to create a series of library maintenance strategies. And that library of maintenance strategies is what we would call our components. So we might have a component with a maintenance strategy for a pump or for a compressor or for a motor. And that then becomes our kind of our master strategy that we'd be applying for that particular make and model of pump. So that would be the main kind of strategy that we'd capture. And that would then be effectively captured as part of a component library. What we then want to do is match that component and that maintenance strategy on that library to the actual physical assets that exist on site. So there may be on that site, we might have 3 pumps that are all the same make and model, and therefore would potentially have the same maintenance strategy applied to it. So that one pump library strategy can be applied directly to the same 3 make models of pumps. And then if we grow that, so effectively we then have maybe 3 areas of a site or even 3 sites which are using the same make and model of that particular pump, it means that we can then link all those pumps effectively back through to that single pump component strategy. So then if we want to make a change, so we want to make a change, this particular strategy that's on this particular pump here, we can then push that change back to our main master component, and then that change can then be pushed out to all the other pumps that carry the same make and model, if we want to. We don't have to do that, but if we want to, then that's a logical thing to kind of do. And that means that you can build maintenance strategies across many thousands of assets, relatively quickly. So it's quick and easy, and when you're basically cloning those strategies and applying them across the different areas.
Hey, David.
Yeah, mate.
So just checking in with time. How are you going with your slides?
Yeah, I am doing Not too bad, I think. What time did you want me to wrap this up?
I think we've allowed, it was half an hour. I think we started 10 minutes.
Yeah, so I got about 10 minutes just to push through the rest.
Yep, I've got a couple of questions, so let you go.
Okay, no worries. All right. So once we get to that, once we've got our strategies then, and we've applied them against our physical assets, the final piece of this is then we really look at our strategy planning. So we want to take those strategies, and we want to then group them into packages of work that can then be delivered into our SAP or our Maxima or whatever that may be, and then provided to our maintenance teams. So that's, again, the final piece, I guess, of what 1PM can provide. It can link either directly to that CMMS, or it can provide the necessary output to allow that interaction with those applications to be performed. And again, we can provide documentation straight out of the piece. So that's really the work that we were doing with Icon Water. You know, they effectively might have a new project build, or even their existing assets. We'd capture that equipment list, we'd build the asset hierarchy with them, we'd delve into our library of maintenance strategy work, identify where we had common strategies, look for any local variations, and then push that strategies out to all their assets. They then take those strategies, package them up to deploy them into their CMMS, which for them I think is Oracle. Would also generate some documentation and ensure then that there's a good match between Oracle data and the data we've got in 1PM. And then we're then pushing that out again to some form of dashboard to allow some management and reporting of all that work that's been performed. We might trigger some RCA investigations, maybe some defect elimination style of things, and we can also apply all this into a workflow. The aim being that as maintenance changes are applied, or design changes, or local regional changes are applied, it all forms part of a workflow that comes back into 1PM, so that the flow continues back through 1PM back into the CMMS. And then we can also add into that activity the work that we've been doing, say on reliability block diagrams and so forth. So this, you know, in a nutshell, this is all the work that we've been doing with Icon Water over the years. And, you know, I think they'd certainly be highly, they'd offer some good recommendations, I think, on this kind of work that they've been doing. So I wasn't sure if you're aware of this, so I wanted to ensure that I share the work that we've been doing with them with you. So, you know, in terms of 1PM in itself, we've got many clients now globally. This is some of the clients that we currently have that are using 1PM on a day-to-day basis, and so forth. There you go. So that's kind of 1PM. In terms of training, which is kind of my area, we offer training. So we can provide training, as I said before, on reliability and root cause analysis, and then software. And we normally deliver around about 200 training courses each year as a company. Those courses can be delivered privately, publicly, face-to-face, or we can do them virtually as well. And so the courses that we offer are all included on our website, but we kind of sort of try to start really at the base level, really, of introducing people to reliability, maybe extending that a little bit so people can understand what some of the methods are that might be used with the reliability. We can talk about FAMICAs and reliability centered maintenance, and also reliability block diagrams, as I just mentioned before. We've got courses that talk about the software that we use. Then finally, we've also got courses around RCA, which in reality is some of our most popular courses. So we have a lot of interested clients who want to learn how to do RCA following a particular methodology. So we can offer those courses, and I think, you know, I've put on here a list of our courses. I've also put some kind of indicative prices for those courses. If we were to run a course, say with 10 people on it, these are some of the prices that we'd be charging for those courses. But we also offer those training courses on a public basis as well, where 1 or 2 people can join potentially a course. And again, we have a calendar, which again is shown on our website. So that's some of the stuff that we offer for training. So I mean, you know, in a bit of a nutshell there, that's kind of what we do as a company. We're providing the services support, the training support, and then I've kind of given you a bit of a taster there, I guess, of 1PM and what that is and how we're using that, I guess, with Icon Water. So I think, yeah, that's all we really wanted to share. Hopefully short and sweet. How was that for you guys?
No, that's really good, David. Perfect timing. I did have a quick question before I jump into the questions in the chat. Maybe if you could, you say apart from the training, which you've shared the cost and the pricing for, you said, you help a lot of organizations with the actual investigations, carrying out the investigations, facilitations, analysis, RCM, and all that. Could you maybe give us a rough indicative cost? Maybe let's say if one of us wanted to engage you for that piece of activity, just high level. I'm sure we'll reach out if we're interested.
Yeah. Well, let me give you some. I guess I'll give you some really broad examples. Okay, so let's say some of the work we did with Southeast Water, for example. So when we're modeling, a site like Mount Martha and doing a reliability block diagram based approach, and that's obviously quite a significant collection of work. It takes many days and weeks, and certainly some of those projects may be extending to months and months of work. I guess as a start point, that sort of work might in terms of just an engineering time would probably be sort of around the $50,000 sort of dollar mark for a series, that sort of series of work. I mean, as a very broad estimate, our engineers are charged out at an hourly rate or a day rate, and I guess their start point really would be about $1,500 a day for the work that they do. Now, if that work that they're doing is more complex and requires a higher skill set, we might bring a senior engineer or a principal engineer, and obviously their charge rate would be a bit higher. The more work we do, the longer it goes on for, obviously the cost would probably come down. But just to give you, a real sort of indicative kind of cost for that services-based work, the training, as I already showed you there on the slides, is already covered there. And as this is recorded, I guess you've got those prices. But anything you're interested in, just reach out, of course.
Yep. I might just jump into the questions in the chat. We've got a question here from Harry. How much similarities do you think exist across similar facilities like pump stations, etc., and how how that can be capitalized to create a consistent approach in developing asset management and reliability strategies for each portfolio?
100%. I mean, really, that's why we developed 1PM, because we were being brought in as a consultant to do maintenance strategy work, and we were using the Isograph piece of software, as I say, which is quite a small piece of software. So you build that strategy, and then it would be provided as an output, and then we'd have another part of the company or even a different company almost asking exactly the same thing, and we go through the same process again of developing those maintenance strategies. And it's like, well, why would you do that when we've already done that work already? Let's build ourselves a software tool and a library to be able to pull that in. And a pump that exists on Southeast Water's site is probably going to be a very similar make and model output, have all the same sort of failure modes and maintenance strategies as a pump that BHP might be using to pump some of their process water on one of their mine sites. It's the same equipment, really, when you break it down into failure modes and maintenance strategies. So there's and certainly that's why I'm interested to present here to you guys, because obviously you're part of this network. So it seems to make sense. If you are happy to share stuff, then why not create a library of maintenance strategies across the network that you can then push out, and people can leverage that knowledge without you all having to reinvent the wheel every time. That seems, certainly if you're all of interest in that sort of philosophy, then it seems to make a lot of sense to me, which
No, we're all about sharing here. That's for sure. Got another question from Callum. Could this technology be used to inform process intensification, such as getting increased treatment capacity out of a structure, or is this something that another part of Arms reliability could look at?
I think if you're talking about it from a reliability viewpoint, or maintainability, then absolutely, that's what we can use those tools for, to support that. If you're talking about water flow and the whole dynamics around that, then obviously that isn't what our tools are. They're purely focused on reliability and maintainability. And I'm sure you guys have got far more specific software tools that you might be dipping into to look at water flow rates and taking into
process optimization.
Yeah, that kind of stuff. I don't really see that as this kind of tool. It can certainly support some of that, but it's more around reliability and maintainability of the assets and how that impacts the base flow figures that are being captured.
Okay. Thanks, David. All right, we've got a few more minutes, so let's see if we can get through these questions.
I just saw a question right down the bottom. It says, "What's the price for 1 PM?" Oh, that is a good question, and it's not an easy answer, right? So, I know you guys are a very interesting price on stuff, and I understand that, of course, because everything's budget driven. So, like for availability workbench, for example, we're talking like $10,000, $20,000 for the software and a license. When we talk about 1 PM, which is inexplicably, exponentially bigger than that as a piece of software, then obviously you're into the hundred thousands of dollars for a base piece of software, and obviously that would grow, as the number of assets grows and number of users grows. So the likes of BP, who use 1 PM over in America, they've got millions of assets captured in 1 PM, and obviously the cost of that piece of software then becomes significantly larger. So it's really tailored around, as a lot of software is these days, on number of users, the size of the database that you're going to be using, the number of assets that you want to start capturing. So it's
Sorry, David. To interrupt. Is that something you can provide, or do you have like number of users or number of assets equals this amount of dollars? Okay.
Yeah. It isn't. I don't think there's like a simple sort of price list where it goes this. Because it's very much tailored to the client. Every client's different in what they want to use. Do you want to? There's all sorts of features on it. Do you want to have RCA built in? Do you want to do packaging? Do you want to have load sheets? Do you want to have direct integration with your Maximo system? There's almost an infinite number of opportunities. So it becomes quite bespoke. But our sales team would certainly have some, because everyone's going to ask, right? They're going to have some basic figures of what it would cost, so you can get a ballpark budgetary figure.
Okay. I'll probably end with this question from Kandasamy. He says, could you give some cost benefit data percentage, such as normal PM and our RCM for a water treatment plant or wastewater treatment plant of similar capacity? How often do we need to review RCM for plant? Are you doing FME and then RCM?
So what's the question? The question is more benefit. I guess, the thing with water treatment plants is unlike a mine site. So when I go and do an RCM study on a mine site, the biggest driver for doing that study is the cost of downtime. So if a mine site goes down, it can be, say, $300,000 an hour of lost revenue as a result of that site being down. When you talk about a water recycling plant, the cost of downtime isn't the biggest factor. It's other things such as environmental impact due to a spillage or fines or general reputation or whatever those consequences might be. So they don't necessarily have a cost that you're driving towards to try to mitigate with doing that maintenance. So it is a little bit harder to necessarily offset that justification for that maintenance if you purely look at cost. So for a water recycling plant, we tend to have to look at the bigger picture of, if a consequence occurs, what is that impact? Not necessarily just from a cost viewpoint, but from everything else.
Thanks, David. The question just pops up. RCM can be applicable to tanks and water and supply network assets. I can say yes. Yep.
Yeah, 100%. Yeah. So tanks would have failure modes around fatigue, corrosion. There might be water level sensors within it, valves, all sorts of stuff that would be completely applicable and have failure modes and maintenance requirements. 100% walkways. Yeah, absolutely.
Perfect. Okay, I think we've gone a bit over time. We might.
I wouldn't worry about that too much, Prith. I think all the questions are good. I think there was one there.
Yes.
I missed asking about condition
SCADA.
performance monitoring
Yeah, SCADA data.
inputs to trigger work packages. Yeah.
So that's great. I mean, you just saw, I've called myself Arms Reliability, but we recently got acquired by Baker Hughes. So Baker Hughes is this massive 60,000 person company in the States, and Baker Hughes are buying up a lot of smaller companies. One of the companies that they've owned for quite a while is a company called Bentley Nevada, and Bentley Nevada make condition monitoring equipment, anything to do with asset health, performance mapping. So, like say vibration transducers that you might put on a gas turbine, they would be heavily involved in that sort of hardware equipment. And to support that hardware, they've also got their own software, which then takes the output from that hardware and tracks it in real time and provides a client with a real-time understanding for how that asset is performing and how its health is performing, deteriorating, and then at what point do they need to intervene to improve the health of that asset through maintenance or whatever, the changing operating parameters, whatever that may need to be. So that's Bentley Nevada's kind of area, and we're Arms in our sort of main strategy development area. So the coming together of us through the acquisition by Baker Hughes is a sensible, logical kind of thing. So what is happening with 1PM actually is it's currently going through a bit of a rebranding, and the work or the software systems that Bentley Nevada have got and the software that Arms have got with 1PM are going to be kind of joining, kind of talking to each other a bit better. So what you'll see in the future is performance monitoring and the triggering of tasks kind of being fed across from Bentley Nevada's software across into Arms, and that will effectively all become as one over time with a new brand and all sorts going on. So but in terms of triggering that work, so 1PM isn't a work planning piece of software. That's generally your SAPs and your Maximos and your Oracles or whatever. They're actually doing the work planning and execution kind of stuff. 1PM is all about validating the strategy of the work that you're actually going to do. Is it the right strategy to be doing? If it is, push it out into SAP and execute it. But is it the right strategy? So we're not really triggering the work in itself. That's done by the CMMS. We're all about trying to judge whether their strategy that actually is in the CMMS is the right strategy. If that makes sense.
That's good. I think that sounds.
So yeah, so 1PM is not an SAP Maximo competitor at all. They're totally different fields of expertise, I guess. What we want to do is build the strategies, make sure they're the right strategies that are justified, and then push them into the SAPs and Maximos so they can be executed.
Sorry, I have to jump in. Next additional question: how do you optimize the strategies? So you can develop several strategies, but do you have an optimization process within the PM to identify what's the most optimized strategy?
I can show you that, kind of easily here. If you got time, like if you give me 2 minutes, I'll just show you what that might look like. And I won't do it in 1PM because that will take a bit longer, but I can do it in Isograph's availability workbench, and I can do it using a model that we built, that me and Prith built. I don't know if you remember this, we did this a couple of weeks ago. But here's a pump. Here's some failure modes within that pump. One of those failure modes here is a bearing collapsed failure mode, and we've captured some data such as what are the effects of that failure. We might have a production downtime impact and maybe a health and safety impact. And then against that failure mode, we've looked at failure frequencies. So we've looked on average, how often is that failure going to occur? These figures here are in hours, but let's say it's around about every 6 years. And then we've looked at what are we going to do when that failure occurs from a recovery viewpoint. So we've got a corrective maintenance task here, which is to replace the pump. And let's just look at that from a cost viewpoint. We can run a little simulation on that, and we can see that over a lifetime of say 10 years, the cost of running that particular strategy and replacing that pump when it fails is going to cost us about $151,000 just for that failure mode. So we may think $151,000 is quite a lot of money, so we ought to do something about that and try to mitigate some of that cost. So what the first thing we could do is we could do a planned maintenance approach and replace the pump in a planned manner. So how often should we do that? Well, we could optimize that interval and get the software to do the hard work for us, and just run a little sequence whereby we look at what if we change the pump out every week, or every 2 weeks, or every 3 weeks. How does the cost going to change? So if we change it out every week, it's going to cost us a huge amount of money, because we're basically over maintaining that asset. We're changing that pump out far too frequently, and the cost is high. But as we push that interval out, the cost of doing that replacement reduces until we come down to a nice low point. But if we push that out further, the cost starts to increase again, because we start to suffer unplanned downtime because we haven't changed the pump out frequently enough. So we look for this kind of shape here, and round the bottom there'll be a cost that round about, in this case it's saying 29,000 hours you should do a replacement. That's the optimal time from a cost viewpoint. On this graph we're also mapping safety criticality, because we had a health and safety effect against this failure mode. So that's one option, right? We could do a planned maintenance replacement at 29,000 hours, and it would cost us around about we get that, it's around about $24,000 if we were to do that. So we could accept that and apply that as a strategy. So our run to fail cost 151,000, but if we did it as a planned maintenance approach, it would only be $25,000. So clearly we can see there's a good cost benefit for us doing that strategy as a planned maintenance approach. It's about 90%, 85% cheaper to do it that way. Or we, rather than doing a straightforward fixed change out, we could actually do an inspection approach, and we can inspect it, and maybe we can do some vibration analysis on that bearing and ascertain when is it likely to fail. So then how often should we do that interval of that task, that inspection task in the vibration analysis? Again, we can do an interval optimization. And again, if we do the inspection too frequently, the costs are going to be high, but over time those costs will start to reduce until a point where they start to increase again, because we're not inspecting it frequently enough. So in this case, it's suggesting around about 2,000 hours, which is about every 3 months, we should do an inspection of that pump. And if we agree to that and look at what that cost looks like, then we're down to about $13,000. So we're now down to about a 92% saving of cost as a result of doing this strategy from an inspection viewpoint. So when we say maintenance task optimization, that's what we're doing here with this. So this tool here is like a little simulation engine which does some calculations for us in the background, and it allows us to then optimize the interval of either doing an inspection task or a planned maintenance task, or we can also justify running things to failure if the actual risk is not, or the costs are not so high. So we can allow this really to do our RCM study justification. Does that make sense?
Thank you so much, David.
Thanks for the question, Harry.
Everything that I've showed you there, that was in Isograph's availability workbench. You can also do all that in 1PM as well. It's just so much easier for me just to demonstrate it just a bit quicker there without me having to go on to another server, because 1PM runs on a server, so just easier to do on a desktop.
And I think you'd be happy to, if anybody reaches out to you, David, to have a bit of a demo outside of this. Yeah,
absolutely.
Share that.
100%.
I think we'll share your details and obviously this recording with the with everyone here. Any final questions or comments before we wrap it up from anyone? No. Okay. Well, thank you for that, David. Thanks for your time. I know we've pretty much gone for more than close to an hour, I think. So thank you for that. I think it was quite useful.
Thanks very much. Thanks for allowing me to present to you. Been good.
Lisa, back to you, or Callum? No.
Callum?
No, I think that's good. Thanks very much, David. Always good to just see everything that's out there. It's not something I've never heard of before. It's pretty useful moving forward. So good to hear about it. Thanks very much.
Yeah, no problem at all. Thank you.
I guess the only thing I'd add from an IWN perspective, if there's any further information that people want, David, are you happy for us to
100%.
pass that on to you and and also, you know, reach into IWN to see if there's any further work that we can do in this space as well? So that would be the only other bit that I'd add on to the end of this discussion.
Yep, no problem. Just use me as a funnel and I'll try and channel your questions to wherever it needs to go, but absolutely just push it all through me, that's fine.
Fantastic.
Don't forget the training, Peter, because my role is training, so don't forget the training aspect.
Oh, you know, we love a good bit of training.
Exactly. Training's great.
Thank you, everyone.
No, thanks, everyone. See you next time.
Can I just say one more thing too? Just before everyone leaves, we have sent out an invite for a lunch and learn for Modeler at the end of this month as well. So if anyone is if they haven't got that email or if they're interested in that piece of work that's going on, give us a shout out as well, and let us know if you want me to forward you the invite. It's on the 30th. Pretty sure from memory, for that particular lunch and learn as well.
Very
Perfect.
good, thank you.
Thanks
Lisa.
team. See ya.
Thanks, everyone.
See ya.
Bye.
Yeah, bye.
Bye.
Later.